Alright, so we have this example problem where you have a plane propeller that starts from rest, and after 3 seconds the propeller is rotating into 75 radians per second. And we want to know what is the angular acceleration if it's constant, and through what angle does the propeller rotate in that time frame, so in that 3-second time frame. So it starts from rest. We know the initial is 0. We know time. We know angular velocity final because it's 75 radians per second. And that's pretty fast because you think one revolution is going to be 6.28 radians. So you take 75 divided by 6.28. And it's almost 12. So it's rotating around almost 12 times every single second. And our goal is to find angular acceleration, assuming it's constant, and to find the change in angular position. Alright, since we need to find angular position, there's only one equation in our list of constant acceleration equations that we can use, and that's the idea that the angular velocity final equals angular velocity initial plus angular acceleration times time. So I'm going to plug in my 75 radians per second, and that's going to equal 0 plus the angular acceleration times the 3 seconds. So that gives me my angular acceleration to be 25 radians per second squared. Now I need to find delta theta, the change of position. And since we now know both time and both of our velocities, we have several options. I chose to use the equation the change in angular position equals initial angular velocity times time plus 1/2 angular acceleration times time squared. So I plug in 0 times the 3 seconds, which is still 0, plus 1/2 times 25 radians per second squared times 3 seconds squared, and it gets me 112.5 radians. So in a 3-second time frame, it rotates around a lot, or about 18 times in that 3-second time span.